Alright, so taking a look at your homework, let's see, on page 496 I asked you to do 31, 35, 55, and 59. Alright, so they're all pretty much the same. I think 59 looks like it's a good one. 31 looks pretty easy, so I think what I'll do is we'll do number 35, which was x minus y plus 3 is equal to 0, and x squared minus 4x plus 7 is equal to y. And we'll do number 59, and then I'll pick some on page 505. Number 59 says y is equal to x to the third minus 2x squared plus 1, and y is equal to 1 minus x squared. And then on page 505, I asked you to do 25, 27, and 29. Alright, 25, 27, 29. So 25's fractions. You guys could just get rid of a common denominator for those. Maybe what I'll do is I'll do 29, you just multiply by 10. So I'll do 25, which is 3/4 x, plus y is equal to 1/8, and 9/4 x plus 3y is equal to 3/8, and I'll do number 27. It says x plus 3 over 4 plus y minus 1 over 3 is equal to 1, and 2x minus y is equal to 12. Alright, now you might do these a little bit differently than I'll do them. It doesn't matter as long as we still wind up with the same answers. So let's take a look. For this first problem, we want to try to get the solution. So I'm just looking at this. If we get y by itself here, we get y is equal to x plus 3, and then we could substitute that in right here. So that would be x squared minus 4x plus 7 is equal to x plus 3. Bring those over. So x squared minus, let's see, if you bring the x over, that becomes minus 5x, and subtract the 3, that's plus 4. We get x minus 4 and x minus 1. So x would be 4 and x would be 1. And then if we plug those in to get what y is, we get y is 4 plus 3 is 7, and 1 plus 3 is 4. And for the second problem, we do know what y is equal to, so we could just use substitution and say that x to the third minus 2x squared plus 1 is equal to 1 minus x squared. Now if we set this polynomial equal to 0, we get x to the third minus, let's see, if we add x squared to both sides, we just get minus x squared, subtract the 1 over, that's what we get. We could factor out an x squared, and we'd be left with x minus 1. This would give us x is equal to 0, and this would give us x is equal to 1. Now we could plug those in and get what y is. If x is 0, y would be 1. And if x is 1, y would be 1 minus 1 is 0. Take a look at number 25. What I would do first is just get rid of the common denominator, or just get rid of all the fractions. So I'd multiply both top and bottom by 8. This would be 6x plus 8y is equal to 8, or I'm sorry, is equal to 1. And the bottom would be 18x plus 24y is equal to 3. Well, I could multiply the top by negative 3, and that would be negative 18x minus 24y is equal to negative 3. Combining that with 18x plus 24y is equal to 3, we get 0 is equal to 0, which is an example of a consistent and dependent system, which means that there's infinite solutions. And then for our last problem, let's get rid of the fractions first. I'd multiply the top by 12. That's the least common denominator. And we get, well, 4 goes into 12 3 times. So we'll do 3 times x plus 3. 3 goes into 12 4 times, y minus 1. And that's 3x plus 9 plus 4y minus 4. So this would be 3x plus 4y is equal to negative 4. 9 minus 4 is 5. If you bring it over, you get negative 4. And we still have the 2x minus y is equal to 12. Well, if we multiply the bottom one by 4, we could use elimination. And 3x plus 4y is equal to negative 4. 8x minus 4y is equal to 48. So 11x would equal 44. X would be 4. If x is 4, we could plug it in here, and we'd get 2 times 4 minus y is equal to 12. So negative y would equal 12 minus 8 is 4. And y would be negative 4. So solution for this one would be 4 comma negative 4. All right, so stay tuned for today's lesson.